So let's look at question number 4. We did a 1D Laplace equation. Now we are going to look at 2-dimensional Laplace equation where isosecond derivative equal to 0. Consider a square region of 0, 1, 0, 1 with boundary condition, this one. So you're asked to discretize the domain into n times n point and set up the finite difference equation for these interior points and solve the linear system using spare, Skype, SP solve, and then plot the potential of sine xy using contour board. So let us look at so we are asked to construct a 2D, 2-dimension xy. Okay, so this grid n times n start from 0, 0 to n minus 1. In order to use a Skype solution to find, in order to use this one, you need to flatten it into 1 dimension. So how to flatten it? Okay, you can use index k equal to I plus jn to flatten it so that you can track each element by using the equation. So for example, got 4 times 4 grid. So you got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you apply this equation. Each equation give you the index element, okay, so that it give you a correct mapping to the 2D system. So your 2D index ij map into 1D index. Next, we are going to look at the finite difference method, and we have a x and y dimension is equal to 0. The standard difference approximation for the second derivative is given by this equation when I plus 1 is the index in the grid of I plus 1, and this where j is constant here, and j, then I minus 1 before the I. That's why you call it central difference. The same thing can be done for the y equation. So you compile these 2-dimensional Laplace equation, you get a 0. You can arrange the equation. We arrange it. Okay, it becomes like this, equal to 0. So this is the central. This the x, okay, before and after, then for I, and then for j. J is the y, x is the I. So you can actually arrange it. So k equal to I plus j in 1D mapping. Can translate it into this, okay, this equation, and the grid is given by kk because central. Then you can translate all this, become this, okay, plus 1 minus 1 plus n minus n. So there's a okay, n, so plus n and n. You have boundary condition, okay, with a kk equal to 1, ensure that the boundary condition is satisfied at 0. Wait, A become 1, so the boundary condition is satisfied. And then you translate this into code. Okay, now look at the code. Okay, I have 100 points. So you need space to get the array. So dx dy is the distance between two. Okay, grid of n plus n. I want to initiate the matrix. Okay, D is 100 times 100 matrix is quite a big one. Very big matrix. Then in order to do it properly without causing memory problem, we use the lean matrix. Okay, from sky B. Space means that my element mostly 0. So lean matrix, okay, is a structure constructing space matrix incrementally. Okay, note that inserting a single item can take linear time in the worst case. So to construct matrix efficiently, so the matrix make sure the items are pre-sort by index per row. Okay, what does it mean? So I have a matrix like this. Okay, lean matrix 5 times 5. Okay, so my A 10 5 8. Okay, I ask to print A, only print this one, and the rest are not shown. Okay, because this is an efficient way to store the element, assuming the rest are 0, so the 0 does not take in the memory when you do this. So you can convert A to array, then it will come like this. Of course, there is efficient way to add more value. Okay, for example, add this one. Okay, plus 5. Okay, so this is a spare matrix. It's a good way to create a value while the rest are 0 and use the memory efficiently in this case. So that's why we do this one. So B, okay, all 0. Now I map 2D in text into 1D using this equation. Apply the boundary condition as stated. And then for interior, I translate this one into the code. Then my A are constructed, but I need to convert A into CSR format for efficient solving, because there's a lot of 0. What does it mean? Okay, convert this matrix to compressed spare row format. For example, what does it mean? I've got the matrix, spare matrix. Inside the computer, it will do this. Okay, data, because the rest are 0, so the data is like here. Got 1, 2, 3, 4. And where is 1 located as in text? For its non-zero value, record its column in text. So 1 is at the column 2, 2 as a column 0, and then step 3 they create a pointer inside system to point where exactly in the rows. So this is all done internally in the system. Then I use this equation to SP solve, to find my B. Okay, solve the spare linear system of AX equal to B, where B is the vector. So you can solve your equation. So you have this equation, the matrix equation. It can decompose into a linear system of equation. When you put in the matrix, it will like this one. Okay, mostly are 0. Then you can use this method to solve your equation and reshape back into a 2D dimension. Then use XY MP match grid to create your data, your graph, which give you this equation, this graph.